Alright, so now here we're going to, in this video, practice with some examples of, basically we're going to be finding x or some measurement using the relationships that we just learned. So let's go ahead and do that. Let's look at this first example right here. I'll call this number 1. In this first example, we're asked to find x right there. X represents that angle that's formed between this line that's like an extension off of a radius and this other end of the tangent line over here. Well, let's remember that the relationship that is formed here between this radius and this tangent line is there is a right angle, or they are perpendicular to one another. So that gives us a right triangle, making this a very easy problem. We know that the two acute angles in a right triangle are complementary to one another. So in order to get x, we'd have to do 90 minus 58. So x would be 32 degrees. And that's it. Some of you all may go through the process of doing 180 minus 58 minus 90, and that's okay too. You should still get 32 degrees. Let's take a second example. Example number 2. Let's say we have a circle in this example. And this time, instead of finding angle measurements, we're going to have to actually find some segment lengths. Let's say we have a radius here, and then we have an extension off of a radius over here, and then this is tangent right here. So I have formed a triangle here. We know that the lengths on this picture are, this whole piece out here will be 8. This is x. This piece over here is 2. And they want us to, as we did in number 1, we need to find x. Well, let's think about the relationships again. If this is our given problem, as it is, and they want you to find x, the first thing that you can put in your picture that you know is that the radius is perpendicular to the tangent. Okay, we have a right triangle that we're looking at here. Now we just need to figure out the side length. Well, we have this leg that's x and this leg that's 8. Then we have this hypotenuse, but we've only got part of it 2. But if you notice that this part of the hypotenuse is actually the radius. So if this is x, then this radius over here that's drawn must also be x. And if we have that, then we can go back and do the work now for finding the value of x. We can put it into the Pythagorean theorem, where c squared is equal to a squared plus b squared, c being the hypotenuse. So the hypotenuse is this x length plus that 2 length, so that's x plus 2 all squared, should equal, a and b are interchangeable. I'll write them like this, x squared plus 8 squared. Let's simplify. So x plus 2 all squared, I should get x squared plus, I'll end up with 2x and 2x for my inner and outer pieces, so that'll give me 4x plus 4 for the last part, should equal x squared plus 64. If I subtract x squared from both sides, they will make 0, leaving me just with 4x plus 4 equals 64. Let's subtract 4 from both sides, and I have 4x equaling 60, thus x equals 15. Great. So we've done 2 examples. Let's do a couple more. Let's clear this out. The third example that we're going to do will also require us to find x. Let's say we have 2 circles here. For example 3, we have 2 circles, and they typically call these pulley problems, because as I draw this, you'll see it looks like a pulley. So let's say we have one line that goes like this, and it's tangent to both of these circles, and then you have another line that will go from the center of this circle to the center of this circle. Okay, and then we're going to connect their radii to the point of tangency. Okay, and the only other information that they give us is that this length between those 2 points of tangency is 25. They give us this length over here is 12, so it has a radius of 12, and this circle has a radius of 9. And they want us to find x. All right, now let's go forward and find that. The first thing I'm going to put in my picture so that I can find x is the information that I know. I know that these are perpendicular. All right. I also can play a little trick here, because I don't have a right triangle yet. That's what I'd like to have. That's what I've been working with. That I could draw a line that kind of goes across here that would also be parallel to that tangent line out there. So it's going to be perpendicular as well, making this 25. And then I'll need this little piece. Well, if the whole thing is 12, and then this much of it is 9 because that's a rectangle, then this must be 3. All right, now that I've done that much, I can find x. It's just a right triangle with a missing hypotenuse. So x squared would equal 3 squared plus 25 squared. X squared would equal 9 plus 625. And so x squared equals 634. And I've already checked, when you take the square root, there's no simplifying of this. It breaks down to 2 and 317, and both of those are prime. So we have found x is the square root of 634. That's our third example. All right, one last example we'll throw in here, one last example. Because all of these examples, as a matter of fact, I'm going to go ahead and clear this, because all of these last examples involve using that first relationship that the radius is perpendicular to the tangent. This last example, number 4, will involve our other relationship. Let's say we have a circle and it's got 3 tangent lines around it. Like this. Okay, the information that they give us is that this side over here is 9 meters. They give us that this piece right here is 6 meters. And that this bottom piece, the entire thing, I'll use arrows to denote that I'm talking about the entire thing, is 8 meters. And in this problem, they want us to find the perimeter. Find the perimeter. So the perimeter is the sum of all the sides. And you can see that we have this whole side, 9 meters. This whole side is 8 meters. And just a part of this side. So the piece that we're missing in here, we have to find. I like this kind of problem because you'll see it'll kind of be a little bit of fun here. Each one of these has a point of tangency. And we know that we can think of our, I don't know if I use this in the proof video, but I call it the ice cream cone thing. So if I ignore sort of the other pieces of the ice cream cone up here, there's ice cream cone, then this piece of the ice cream cone better be equal to that piece, because otherwise it will tip over. So this must also be 6 meters. Well, if this is 6, then this piece down here must add to make 9, so this must be 3. Now, again, we don't go off of how it looks, but we know that mathematically 6 plus 3 must equal 9. Right? Now, this side, we have a new ice cream cone. This is 3. And this part over here must also be 3. And then to make a total of 8, then this piece must be 5, leaving us with this unknown part. Oh, I know what it is now. It is 5 meters. Now we can find the perimeter. The perimeter will equal, I'm going to do it by sides. Let's take this whole side, which was 9. We knew that. Plus this whole bottom side, which was 8. We knew that as well. Plus now, this was the part we didn't know. 6 plus 5 would be 11. So the total perimeter is 28. And then we'll put the meter sign by. There you have it. All right, we'll see you in another lesson.